All right, the last misleading one we're going to go through is three-dimensional graphs. Newspapers and magazines often represent three-dimensional bar graphs just because they're more visually impressive. They look cooler than the other kind of graphs. Unfortunately, in order to make the tops of the bars visible, these graphs are often drawn as though the reader is looking down on them, and this makes the bars look much shorter than they are. It also makes it really hard to figure out. It's like, what does this line up to? Does it line up here? Does it line up there? Where is it actually lining up at? Am I supposed to go diagonally? Does it line up here? Sorry, like this. I don't know where the actual lines are because it's sort of moved away from the edge. So it makes it really hard to judge the actual values here. Because like this one, if this is that jet fuel, I know that this one should be lining up about here. Or about here. So where's that line up on here? Where do I measure that? How do I find out that's where it's lining up? I don't know. And this one here, we know this was about, should be about in here. Well, once again, I'm not sure where it's exactly lining up at. So it can make that really hard to read. We could definitely see the part where it looks like it doubles, but I don't know the actual amounts. So this is another example of, it doesn't apply just to bar graphs. It also applies to doing three-dimensional graphs of, say, pie charts. So describe how the 3D version of the pie chart misrepresents the data. So one of the things here is once I tilt it and make it 3D, we see that these two pie slices here, they kind of look a little smaller over here. Or the one that I really noticed was here. So this area is quite a bit larger than this area, right? It's like, if we were to compare them, it's like this. This is definitely larger. If you look at it over here, the orange and the blue look like they're about the same. So we can see here, this is bigger than this. Once I lay it on the side, they kind of look the same. So it really messes up with size. It messes up with trying to actually look at that and estimate amounts. Like if I looked at this here, I can tell you that this orange spot, or especially this blue spot, I could probably tell you that this is taking up about maybe about 80% of the area. Not 80%, I'm sorry. I'm 16 degrees or something else here. This is taking up about 40%, like 45% of the area, maybe. Here, it looks like it's taking up maybe a third. So it skews those dimensions for us.